In this lesson, we'll talk about electric potential energy, and here are your objectives. Now remember that potential energy in general is positional energy. It's energy that is stored in a system as a result of the relative position of two or more objects. So let's say I had a large positive charge here, and I had a smaller positive charge over here, and I started to push the smaller positive charge towards the larger one. As it would get closer, the work that I'm doing, the force that I'm exerting through a distance to push this positive charge towards the larger one, is getting stored as electric potential energy in the system. So over here, when the small charge is over here, the whole system has high electrical potential energy stored in it, as opposed to over here, that electric potential energy was lower. So the work that I've done in pushing the positive charge closer to this larger positive charge gets stored as potential energy in the system. If I chose a negative charge, the situation would be reversed. This would be low potential energy stored in the system because the positive and negative charges are attracting each other. And similarly, if I made the large charge negative, then having a small positive charge over here, again, this would be a system with low potential energy because they are attracting each other, and this is therefore energetically favorable. And over here, this would be high potential energy. And in this system, now moving the positive charge away from the negative charge that's attracting it again takes work. So in both of these setups, it takes work to push the positive charge, the small positive charge, to the left. In the top setup, it's because I'm countering the repulsive forces between the two positive charges, and in the bottom setup, it's because I'm trying to counter the attractive forces between the positive and negative charge. So the work that's done to move the positive charge in both of these cases is stored as potential energy in the system. Let's look now, instead of at point charges, let's look at a parallel plate capacitor system. So let's make this the positive plate, and we'll make this one the negative plate. And I'm going to put a charge in the middle here, and I'm going to make this a positive charge. Over here, the positive charge and the positive plate are repelling each other, and the positive charge, if let go, would zoom towards the right. So this is a high electrical potential energy setup, whereas over here, it would be low again. And once again, if I were to start over here and let the charge go, it would accelerate towards the right. What's happening there is the electric potential energy is being converted into kinetic energy. If I move up and down, I'm not changing the potential energy of the system. I've still got the same proximity between the charge and the plate. So this down here, if I call this setup 1 and this setup 2, 1 and 2 have the same electric potential energy stored in the system, and no work is required to move from 1 to 2 or back. If you imagine tipping this whole thing clockwise, you can think of it like lifting something against gravity. If you have a mass down here, it's got low gravitational potential energy. You do work to raise it up to a height, and now the work that you've done is stored as gravitational potential energy in the system. So in the same way, moving something against the electric force is going to store potential energy in the system. So again, the work done to move a charge against the electric force is stored as potential energy in the system, in an analogous way to the way that the work done against gravity is stored as gravitational potential energy. That's an introduction to electric potential energy.